you did a scientific notation earlier in the year in Mr. Mock's class, and we're seeing it again in algebra, but I think that's an okay thing because it doesn't hurt to review it and see it a second time. Hopefully you remember that in order for a number to be written in scientific notation, it needs to be a number that's in between 1 and 10. So in between 1 and 10, it can't equal 10, but it can equal 1. And that number has to be multiplied by a power of 10. So this is not one word, this is two words. So I can see that these problems right here are already written in scientific notation, but the two numbers at the top are not. The off to the side I have them saying that we want to write them in scientific notation, starting off there in standard form. Well, in order to do that, I first need to make sure I have a number between 1 and 10. At this point, I have 12,345 and 67 hundredths. That number is not between 1 and 10. So I'm going to move my decimal point until I do get a number that's in between 1 and 10. And I am now at 1.2345667. And I need to times it by some power of 10. Now what power am I going to put on 10? Well, that power depends upon the number of places that I had to move the decimal point. So in this case, I moved it 1, 2, 3, 4 places to the left, and I made the number smaller. So in order to go from 1.2345 and so on back to 12,345, my number needs to get bigger. That means I'm going to have to multiply it by a very big power of 10. The higher the power on 10, the higher the value. And because I moved it 4 places to the left, that means my power has to be a 4. And if I were to try to check this and see if I can get back to the original, I'm going to take my 1.234567 and I'm going to times it by 10 to the 4th power. And I should get back to exactly what I had before, which is 12,345 and 67 hundredths. So I just checked to make sure that the answer that I came up with in scientific notation was exactly equal to what we had before. Okay, in the next example, I'm starting with a pretty small number. I have 1,234 10,000ths. In scientific notation, it needs to be a number between 1 and 10. This number is less than 1. So if I move the decimal point here, I now have 1.234, or 1 and 234 thousandths. That is a number between 1 and 10, and I need to multiply it by a power of 10. Well, I took a number that was very small, and I made it just a little bit bigger. So in order, if I wanted to get back to that really small number again, I need to have a small power of 10 that I'm multiplying by. And that small power of 10 is going to be a negative 1. Since I moved 1 to the right, I need to use a negative exponent. Over on the first one, I had moved to the left, so I had to use a positive exponent and a rather large exponent in order to be able to get back to what I started with originally. And just to double check and make sure, I can take my number that I wrote in scientific notation, 1 in 234,000, and times it by, whoops, times 10 to the negative 1 power. Not sure how that power is going to work out, but we'll see. Nope, that wasn't right. And I do get back to the number that I started with, 1,234 10,000ths. Okay, now the nice thing about scientific notation is it allows us to take some really large numbers and shorten them and not have to use so many decimal places after the number. That's the real intention of scientific notation. I didn't use very large numbers to do this. So now I have two numbers that are circled here that are already written in scientific notation. I have 6 and 134 thousandths being multiplied by 10 to the 5th power. 10 to the 5th power is a very large number. 10 to the 5th power is equal to 100,000. So rather than actually sitting here and multiplying that out, I know that my decimal point for every power of 10 that we're multiplying by is going to move one place. So there's the first power on 10, the second power, the third power, the fourth, and the fifth. Now since there's no numbers in those open spaces, those have to be filled with zeros. So 2 open spaces is going to give me a number that is 613,400. Over in the next example, I'm taking 1.3, again it's a number between 1 and 10, and I'm multiplying it by some power on 10. Since the power on 10 is negative, and that's a very small number, 10 to the negative 3rd power, is 0.001 or 1,000th. So I'm multiplying the number that's bigger than 1 by a very small number. So our number is going to get smaller. For every power of 10 that we multiply by, our decimal moves one place. So I happen to be multiplying by 3 powers of 10, and because it's negative, I need to move it 3 places to the left so that my number can get smaller. So here's the first spot, the second spot, and the third spot. All the empty places need to be filled in with zeros. So I would end up getting 13 10,000ths. Okay, and I did see some of Mr. Mock's video on his scientific notation, and I also saw that you were dividing and multiplying and even adding and subtracting numbers in scientific notation. For our purposes in algebra, we mostly do the multiplication and the division because we want to practice our rules for exponents. What do we do with exponents when we're dividing, or what do we do with exponents when we're multiplying? So in the video on exponent rules, you should have learned what to do with those exponents. So basically, this first example here with this multiplication that I'm actually doing division, we can take the value part of this, the part that is not powers of 10, and we can divide that out. And then we can take the powers on 10 and calculate that individually. So the first thing is the 3.2 divided by 1.6. And I don't care how you do that. You can do that by hand, or you can get out a calculator and you can do that. So I end up with 2 when I divide 3.2 by 1.6. Now I need to do the calculations for the exponents. Well, the rule on the exponents when you're dividing bases with exponents is to subtract the exponents. So I need to do 6 minus 3 to come up with my new exponent. So 2 times 10 to the 3rd power would be my answer to this problem that's been written in scientific notation. 10 to the 3rd power would be 1,000. 2 times 10 to the 3rd power would be 2,000 if I had to write it in standard form. I didn't specify on here. Typically, if a problem starts off in scientific notation and they don't tell you how to finalize your answer, then you should end your answer in scientific notation as well. Okay, the next one, I've got the numbers that don't have power. So 1.21 or 1 and 21 hundredths divided by 1 and 1/10 times by 10 to the 7th divided by 10 to the 4th. So again, I don't care how you do the number part. 1 and 21 hundredths divided by 1 and 1/10 ends up being 1 and 1/10. And 10 to the 7th divided by 10 to the 4th is going to be 10 to the 3rd, because the rule for exponents when we're dividing is to subtract them. So my answer in scientific notation would be 1.1 times 10 to the 3rd. If I needed to write it in standard form, I would just take my decimal point and move it 1, 2, 3 places to the right, and it would be 1,100. Okay, now we can do similar things for the multiplication problems. We can take the number parts, the ones that are not written as powers of 10, and multiply them, because it does not matter what order we multiply numbers in. Oops, and I have this original problem, I have these in the wrong spaces. This should be a 3, and then the parenthesis. And then I can take the 10 to the 3rd power and times it by the 10 to the negative 1 power and work on them in groups that way. So I need to find out what my 3.6 times 1.2 is, and that's 4.32. Times, now when I multiply bases that have the same exponent, my rule is to add those exponents. So I need to find out what I get when I do 3 plus negative 1. 4.32 times 10 to the second power. And again, you could take these two values, 3.6 times 10 to the third, and on your calculator, do 1.2 times 10 to the negative 1, and your answer would come out in standard form. It would not come out in scientific notation, but you could take that answer and convert it. I don't know how handy that's going to work on this calculator to show you. This is not the best. The graphing calculators handle scientific notation really well. 10 to the third. Whoops. Okay, so 3.6 times 10 to the third times by 1.2 times 10 to the negative 1 power is 432. If I took my answer that I got down here and change this to standard form, move my decimal point 2 places to the right, I would also get 432. But I'm going to leave it in scientific notation because the problem started in scientific notation. Also, another thing you should do is make sure that you're always checking that this whole, the part that's in standard form, the 4.32, always make sure that that's a number that's between 1 and 10. Okay, if this next example does not come out with a number between 1 and 10, then I'll choose one that does. So 1.68 times 3.7, 6.216. So when I do the 1.68 times 3.7, I get 1.216. 6.216. That's why I double checked, because I wasn't sure. That doesn't make sense that it would be 1. Okay, 6.216 times 10 to the, well, I got to add the exponents. So the new power is going to be 2 plus 4, and that happens to be a 6. And just a quick check, is 6.216 between 1 and 10? Yes, it is. So my number is in scientific notation. Okay, let me see if I can come up with one that is a little bit different here. And we'll do 9.2 times 10 to the third times 8.7 times 10 to the negative 7 power. Okay, so actually let's not do the negative 7 power. Let's just do a positive 7 for now, and we'll do a negative 7 or something like it in the next one. So I want to find out what my 9.2 times my 8.7 is. Gives me 80 and 400ths times 10 to the, well, 3 plus 7 for my exponents. So it'll be 80 and 400ths times 10 to the 10th power. I noticed something with this number right here, though. That is not a number between 1 and 10, and scientific notation requires your number out in front to be a number between 1 and 10. So what I'm going to need to do is move the decimal one place to the left in order to make it a number between 1 and 10. So my 80 just got smaller. And if this number gets smaller, in order to get back to the original, my power is going to have to get bigger. Otherwise, I would never get back to what I originally would have had. So 8.004 times 10 to the 11th is the same as 80.04 times 10 to the 10th. Okay, let me do another example. Let me go back to how I had it, but this time I want to get my negative exponent. So I already know that this is going to be 80.04 because I used the same numbers, but this time my exponent is going to be 3 plus negative 7 will be a 10 to the negative 4th power. Okay, and just like before, I'm checking this number and I see, oh, this is not between 1 and 10. So I'm going to need to make this smaller which means I need to make, and I only moved it one place, so I only need to make my exponent 1 power bigger. Well, what is 1 power bigger than negative 4? It's not negative 5, but it's negative 3. And if we were to do a comparison of these, 80.04 times 10 to the negative fourth would equal 8.004 times 10 to the negative third. And you could check that on, I would check it on the graphing calculators in case you were not sure about that.